Kubernetes for Humans.
Hello, everyone, and welcome to another episode of the Kubernetes for Humans podcast. My name is Itiel Schwartz, and today we have at the show GM. GM, can you please introduce yourself?
If I'm Gianluca, everybody calls me like GM, and I'm a principal engineer at Cisco Systems. And on the side, I do maintain few open source projects around Kubernetes, which I've been working on for the last 3 years now.
Yeah, and at least like one of them is like super exciting. But before we like deep dive into what you're currently doing, do you mind like sharing a bit on your history? Like, how did you start developing? What led you to tech? And then maybe a bit on like when did you first discovered about Kubernetes?
Yeah, so I was doing my PhD in Italy when I got an internship at Cisco. So I was supposed to be 9 months in California, and it turned out to be like 19 years. So now I'm back to Italy after 19 years. But
Okay.
was,
Why are you back to Italy after 19 years?
um, we got 2 kids. I became a citizen, and my kids are with dual citizenship as well. So we decided to give Italy, Europe a try. We thought that we don't want to be like in our 70s and think what would have happened if we had moved back to Europe. So we're giving it a try, and so far so good. But we can always go back now. So that's made the easy,
Mhm.
the choice easier. Yeah,
Okay, sorry, I stopped you. So you started like at Cisco, like in the in
it
the
was.
during the right?
Yeah, so I started like so I went to Cisco 2004, and then I left Cisco and joined Cisco back a couple of times. I like
What made you leave and what made you come back? Like, it is
the
interesting.
last time because I want to start working in Kubernetes. It was 2019, and I had started Kubernetes on my own, but I really want to learn it. So I said, like the easiest way to learn it is if you go to people and work with people who have mastered like 4 years. So I joined Tagara, and the company behind Calico. So I was there. I learned a lot. It's an amazing team. It's an amazing company. Fantastic culture. And then another project started at Cisco, which was around Kubernetes, creating like Kubernetes clusters on-prem on demand. And because it was starting from scratch and they were looking for people who want like to contribute, so I said, okay, sounds like a right time for me to come back. So
Maybe
back
before,
it's
like, maybe even a bit before that, do you mind like sharing a bit like why do Cisco even care about Kubernetes? And he said that you joined Cisco because they have like a very like strong people, but like for me, Cisco is in the end of the day it's not that Kubernetes is the first thing that comes to mind, right? And I'm putting aside like all of the Splunk maybe now, and like now Cisco is huge, right? But
Cilium as well. Yeah.
uh, Cilium is also quite new, right? Like it's not really like
Yeah.
Cisco, and Cilium is very network oriented. So I'm saying, oh, okay, like Cisco is doing network, they bought Cilium, make complete sense. Why does Cisco care about Kubernetes? What's the agenda? What are they trying to achieve? And yeah, like what? Give us like some context and like some background on that area. And
Yeah,
I'm
unfortunately, it didn't last long. This project started because the idea was, Cisco as servers, and Cisco, as networking. The idea was to build to manage Kubernetes clusters on-prem, because it was a tendency already that we saw like years back that people start considering the cost of the cloud and considering like moving back on-prem. And I was, I think considering what has happened like to VMware with Broadcom now, it probably would have been like a great opportunity for Cisco. But the project didn't go far away. We worked like for it on the project for a couple of years, but then restructuring happened and the project was cancelled. So I don't think at the moment like Cisco has anything that big around Kubernetes. So, Cisco is big, and there may be like different business unit that may have some project around Kubernetes. So I might be wrong. At least I view that, it's not, it uses Kubernetes because, it's becoming like, it is the platform that everybody uses it. So it has applications and solutions around Kubernetes, but it's not really much involved now, like in creating those Kubernetes clusters on-prem as the project was supposed to achieve. And when the project was essentially was when I decided like to, I saw something that was missing in that project, and I saw something that I didn't find even like outside, and that's when I started like my open source project, because I do really like Kubernetes. I love it. I love the idea behind it, and yeah,
So
it's.
share a bit more about that. Like what, why, how, like the project.
Oh, the project is because we were using Cluster API, which is great to create Kubernetes clusters on demand. So to create, upgrade, or delete a cluster. So we did develop our Cluster API infrastructure provider. And then in this project, we were managing many things. We're managing the CNI, we're managing the storage, we're managing like the ingress. And one thing I noticed is that everybody was reinventing the wheel, in the sense we had like different controllers, and all those controllers were writing the same code to deploy something in a newly created cluster or upgrade something that is supposed to go to a production cluster or to a staging clusters. And Cluster API is great, but essentially it really stops at the cluster creation. They have something to deploy, resources on a Kubernetes cluster, but it's very limited. And I decided like to do something there, because I like the idea of that you programmatically say what you want, and then either creating a cluster, but the same concepts will apply also now. Those are all the add-ons and applications that I want to be deployed on a newly created cluster. It shouldn't, concept is the same. And so I started working like on Sveltos, because one of the things also that I noticed is that when you start managing more than an handful number of clusters, you have more admins that are involved, because like Kubernetes is so vast that nobody has knowledge of all the add-ons and all the application that needs to be deployed. So very likely you have an admin which is an expert in monitoring and observability. There's an admin who is really good at admission policies, and the idea should be that those admins they can create a set of policies that needs to go to production cluster, and set of policies that needs to go to staging cluster, and set of policies that needs to go to testing clusters. And then when a new cluster is created, the only contract that should be between those admins and admin that is creating the cluster should be, if you're creating a cluster and the scope of this cluster is production, just put this label. And because you put this label, all the policies needs to go to the production cluster, which have been prepared by different admin, boom, get deployed. And it should be like,
Let me stop you for a second, because I think I got you, but let's just do like a recap for our listeners. What you're saying is, first of all, Cluster API is great. Like before Cluster API, even creation of cluster was very like scarce and sparse. And Cluster API makes it easy to have some recipe to create the cluster. But once you have a lot of clusters, then you found that they are not like the same, like they're drifting, or there is lack of standards. And you want not only the cluster, you want to be able to install in the same process, in the same way, the same things basically, and to make sure that they work, which is quite similar. Like if I take you back like 10, 15 years ago, a bit like, I don't know, like Docker or applications in general, you want to have a cluster recipe, right? Like a production cluster recipe. This is a production cluster. It should have, I don't know, like Fluentd, and it should have maybe Datadog and some Cilium or whatever. And this is the cluster. And if a new team wants another cluster, all they need to do is to say, hey, please provide me like a labeled production cluster, and everything will magically works, right? Like did I got it right?
Yeah, exactly. You need consistency in creating those clusters, and you need to be really fast creating those clusters. So you don't want essentially an admin to start doing kubectl apply or anything. You just should be able to create programmatically cluster, and you can do with cluster API, or you can do with whatever tools you decide to use to create the cluster. And then essentially, if you have a management cluster, you can simply say, okay, I'm creating this new cluster, and this is the label for this cluster. And because this cluster has this set of labels, now this is the Cilium configuration, this is the Fluentd configuration, this is the Prometheus configuration, this is the Caverno configuration, and everything. And those are the set of applications which you want to be running in a production cluster, and boom, they're up and running, and it is consistent because you can reproduce, you can do the same things every time you create the same cluster, as long as you apply the same set of policies. The same set of add-ons and applications gets deployed. And also, once as a day two operation, if you realize that, okay, I have 4 production clusters and I want to upgrade Prometheus because there is a CV that has been fixed in the latest release and I want to upgrade to the latest release, there is a single place where you say, okay, this is the configuration for the production clusters and this is the version of Prometheus. You change in one place and boom, gets upgraded in all the other places. So of course, there must be other considerations. You might want to roll out the upgrade like few clusters at a time, but the idea should be that there is a single place where you go and change the configuration for production clusters, and all your production cluster gets upgraded.
No, like sounds super interesting and makes sense. Maybe share with me a bit on the alternative. Like if I'm not using your project, what do I do? I have hundreds of clusters or maybe like a dozens, right? Like I'm a small company. What are the alternatives? Is Crossplane an alternative? Will you say Terraform maybe is an alternative? If not using you, what should I use and how and why?
There are Crossplane could be like an alternative. Many uses a GitOps approach. I do like a GitOps approach. I don't think pretty much what I'm doing like is an alternative to GitOps. So the way I see is that with GitOps, it's fantastic if you have, but it becomes stuff like for day two operation. Let me put it this way: like you can manage a fleet of clusters with a GitOps approach. But let me take one example, like to explain why I think like it's difficult for day two operation. Let's say that you create like a set of production clusters. You create like 10 production clusters. We are all the same. Where you deploy like a bunch of applications, right? And now for whatever reason you decide that you want to upgrade only one application only in one of those production clusters. So you want your cluster to become like slightly different, right? The idea that the way you can do with Sveltos, for instance, is that Sveltos is a concept of tier. So you can introduce like another application which has a tier which is higher than the configuration that you already have. And so what you can say is like, okay, this application is more important. It's matching only one cluster out of all my production clusters, and it's going to upgrade only this application. So what happens is that the application gets upgraded like only in that specific cluster. But the beauty is you're not changing the rest of the configuration. So for sure, all your other production clusters do not get affected. If you go with a GitOps approach, unless you have this in mind, right now it becomes difficult to take that cluster out or change the configuration just for that cluster. And what I'm scared of is that, like if you want to change just a small thing in a subset of your cluster, whatever you do, you must have something and guarantee that nothing is going to affect the other cluster. And of course, if you're going to change the configuration, the risk is there. So I find that there should be a solution that allows you to do those day two operation like easily, and we guarantee that nothing is going to happen to the other clusters. Another thing which I think it's useful is that sometimes you may need you may want to use your management cluster as sort of a database. In the sense, I've created different secrets in this management cluster, which contains different credentials. and I want to deploy this application in all my production clusters. And this application requires some credentials, but the credentials that should go to cluster 1 should be different than the credentials that go to cluster 2, because I'm giving cluster 1 to Gianluca, I'm giving cluster 2 to Itiel, right? So I want to have like different credentials, right? So the way you can do with Sveltos is that you can create your configurations. It's like, okay, this application needs to be deployed in all production clusters, but you express it as a template. And you say, if you're deploying on cluster 1, you should get the credentials from the secret in your management cluster. If you're deploying this application on cluster 2, get the credentials from the secret 2, which is in the management cluster. So now at runtime, what happens is that Sveltos is going to deploy this application on cluster 1. It's going to get the secret, which is in the management cluster, which contains the credential for Gianluca. And so the application gets deployed with Gianluca's credentials. And when it goes to cluster 2, it gets a different secrets from the management cluster, which contains the ETL credentials. And now the same application, exactly the same application, from the same template gets deployed on cluster 2, but with a slightly different configuration, with the credentials which allow pretty much with different credentials. So this is another things that you cannot do like with a GitOps approach, because in a GitOps approach you have everything like in the repo. Or another example would be if I want to pipe, very likely I want to pipe like multiple tools. Crossplane, for instance, is great if I want to create resources outside the cluster. If I want to create a Google storage bucket, I will use Crossplane, right? Because it's very easy to say what I want. Now, assume that I want to deploy a pod in every production cluster, an application in every production cluster, which is supposed to fetch some data and push those data to a storage bucket, right? So every time I deploy this application, I also want to create a storage bucket. So if, I want to create a different storage bucket for every cluster. So what I can do, if I know that the management cluster can be used as a database, now I can say, okay, instruct Crossplane. I create a single configuration that says instruct Crossplane to create a storage bucket. I'll wait for Crossplane to create the storage bucket. When Crossplane is done creating the storage bucket, Crossplane is going to store some information in the status of the Crossplane bucket resources that says like, this is the URL to connect to the storage bucket. Now I can get that URL and then instantiate my pod and deploy in cluster 1. And so now I created automatically a bucket for cluster 1, and I deployed a pod in cluster 1, which is collecting some information and uploading this information to bucket 1. When I need the same application to be deployed in cluster 2, it is essentially the same template, because now it instructs Crossplane to create another storage bucket. It gets this URL from the storage bucket, it instantiates it in place, deployed to cluster 2, and now the pod in cluster 2 collects the data, and boom, it uploads the data to bucket 2, which has been created by Crossplane. So if you want to do like this piping of multiple open source, because there are so many great open source that you want to like likely tie all those things together, having a solutions that where you can chain events and you can use template to fetch data from the management cluster and use template to instantiate those templates with those data and deploy to the various cluster. Now you're reducing the amount of configuration that you're creating, because you're creating a single configuration which boom gets deployed like to various cluster with different data which are coming at runtime from the management cluster. And maybe those data in the management cluster were created by other open source tool at runtime. So you can do like this chaining.
I think what you're describing is, becoming more and more like painful as customers have a lot of clusters to manage. And I think like the problem is indeed there. You didn't talk about it too much, but so what is the best alternative, if any, like in the market, open source, not open source?
I mean, you have to go with, I will say that there are solutions like I don't know if the Rancher fleet is still there, but you may want to look at a solution that it's actually considering those clusters not as individual cluster, but somehow like as interconnected clusters. Because if you're looking at those clusters as independent clusters, you may have a solution that allows you to consistently create a deploy application in those clusters, but then you're missing a part of things that you can do, because Another example, just to make it clear, for instance, this was one example that someone brought up, like, can I do, I'm creating like an internal developer platform. Can I use Sveltos to do this? And their use case was, I want to have the cluster where I have my Postgres databases. And I want my application using those databases to be like in other clusters, right? Because I want to use the default domain, and so I have like different clusters and my database in different clusters. So the idea, the request was, okay, so when I create a cluster, I simply want to label this cluster with the label Postgres required. And because I added this label on the cluster, now I want Sveltos to detect that this cluster requires a Postgres database. Use cloud native PG to create a Postgres database in a separate cluster. Now fetch the credentials of this cluster, expose this cluster, this database with a load balancer service. So get the load balancer port IP, collect the credentials of the load balancer port IP, and boom, send this information to the application in the cluster one that needs to access this database.
Yeah.
And now I can
Yeah.
automate all those things, right? It's you simply put a label
Yeah.
and everything is done.
It's like it sounds like a magical plumbing idea, right? Like both creation of the resources and connecting it to like the cross cluster. I think we are like pretty much close to like ending the episode. There's one thing that I really like to ask is, what's your prediction? Like, where are we going as an industry inside the Kubernetes ecosystem, as in your project? Like, if I'm going to talk with you in 2 years, what's going to be different? Or 5 years, whenever we want to talk.
My hope, like I'm a lazy engineer in the sense that when I do something, I wanna do it once and I don't wanna touch it again. So my hope is that the amount of configuration that we have to create to manage a fleet of ephemeral clusters is gonna reduce to very minimum. And there are tools that are gonna automate everything. Ideally, what I want is that I come and say, if X happens, I want Y to happen, and I express in English, and then there are LLM that are able like to translate this in configuration, either Sveltos or whatever, like other solutions that is going to be there. So translate in that one, put the right configuration, and boom, like anything happens, and we are free to enjoy our weekends, nights, and we don't have to worry about like when something happens and something needs to be done.
No, it sounds like a great future. So with that, I think we will close today's episode. I will share like the project Sveltos project in the footnote of the episode. Pleasure having you.
Thank you so much for having me.
Thank
Pleasure
you.
was mine.
Kubernetes for